Let's go.
F of x equals the natural log of x to the power of secant x.
Which one's got the power?
It's like the natural log is all in, yeah.
Okay, and what's the power up here?
Secant x.
Good. I wanted to go over some more of those. It's like the last one that we did. This uses something called logarithmic differentiation. Well, that gives a very bad shot. And I'm sorry. So remember that when we're taking the derivative of something that looks like a function of x raised to another function of x, that we don't have a power rule for that. So we're going to do something called logarithmic differentiation. And what we do is we take, let me rewrite this as a y instead of an f of x, and we'll try to find y prime. We'll take the log of both sides. Oh, that one's no good. Let's get rid of that one. We take the natural log of both sides so that we can over here use the property that brings the power in front of the logarithm. Now I can't do that yet because that property applies when the power is on the article of the logarithm. This one's not. This one's on the whole thing. So that's why now I need to take the natural log of both sides. Let me use parentheses now. So now the power is on the article of the logarithm. Now I can bring the power down in front. Once everything's on the same line, then we just use implicit differentiation to find y prime. Get everything on the same line using log properties, and now take the derivative of both sides. Where on the left-hand side, the derivative of the natural log of y is 1 over y times y prime. Here we've got to take the derivative using the product rule. So we take the first times the derivative of the second. So we're taking the derivative of a logarithm. So that's 1 over the u times u prime. So I've got 1 over the natural log of the natural log of x. That's the 1 over u part. Now the u prime, I'm in here to take the derivative. And the derivative of that natural log of x is 1 over x. So that's half of the product rule. The other half, copy down the natural log of the natural log of x and take the derivative of the secant of x. Anybody have that one for me? What's wrong?
So after the secant x, wouldn't it just be 1 over the natural log of x to get rid of?
Right, I don't have 2 of them. That's a talking and writing thing. Right. Derivative of this is 1 over that. So there's only one of these guys here. Like you saw that. Then the derivative in there takes that. Now this is the second factor, and the derivative of the secant of x goes here. Who's got that? That's right, secant x, tangent of x. And then the last step is to solve for y prime. So we'll take that whole line and we're going to multiply it by y. And I don't know if I can fit it right here. Can I see it if I put it right there? Yeah, you can see it. So y prime is going to be y times all of this. And I'm going to put this all together. I'm going to put the secant of x on top and write x, ln x on the bottom. Make it a little bit easier for me to write and probably easier for you to type in. the web work. And then I got plus, and then here, there's nothing to simplify. You can leave it there, or if you want, where the y is, you can put this back in. I'm not sure if WebWork wants the function of x or if y is allowed.
Web work plus y.
What's the y back in? So then put this back in. Right here. So let me make up another one of those for you. Okay, so here's a similar one. Take 4x plus x squared, and let's raise it to the tangent of x. And the instructions are to find y prime. See if you can do all those steps here. Pay attention to what it looks like. You've got a function of x on the bottom and a function of x in the power. So don't try to do the power rule. You can't be caught sleeping on these. So you better see it. Think you got it? Take the natural log of both sides. In the next step, I'll put the tangent in front of the logarithm. And now I'm ready to take the derivative. So on the left side, we still get 1 over y times y prime. And on the right side, we've got a product rule to go. Tangent of x is the first term. The derivative of the second term is a 1 over this stuff. And now I have to go in the parentheses there and take the derivative and get 4 plus 2x. And I'll go ahead and slide it over here on the top. The other half of the product rule is I copy down the natural log of 4x plus x squared. And then take the derivative of the tangent of x. What's that going to be? Good. Secant squared of x. Then in the next step, we multiply by y. So instead of putting a y over there, I'm going to go ahead and skip a step and put that y back in. Know what you got? I did forget the tangent of x. Let's put it right here. Good eye. Okay. All right, then let's go back to web work. What else you got for me?
I got summer number 7.
Okay.
It's e raised to the x over y prime
Okay.
equals 2x minus 3y.
And our task is to find y prime.
Yes.
So we start by taking the derivative of both sides. E to the x over y is equal to 2x minus 3y. So when we take the derivative of e to a power, we get itself times the derivative of the power. If you leave the power like this, you got to take the derivative of the power using the quotient rule. Is that okay? So we get itself e to the x over y, and now the quotient rule. The y times the derivative of x is just 1, minus x times the derivative of y, that's y prime, all over the bottom squared. Bottom is a y, so I get to square it. So that's the derivative of the power. And then on the right-hand side, the derivative of 2x is 2. The derivative of 3y is the 3y prime. So we get 2 minus 3y prime over there. What'd you do next? Okay, I want to get rid of this first.
I think I multiplied that.
I'm going to multiply both sides by y squared. Just get rid of this denominator. So there's going to be y squared here, and there's going to be y squared there. So we'll have e to the x over y, y minus xy prime is equal to 2y squared minus 3y squared y prime. We're trying to get rid of all the parentheses we can so that we can get the y primes together. So I still have some parentheses here. And I can get rid of that by multiplying both of those terms inside the parentheses by the e to the x over y. So when I do that, I get y e to the x over y minus x e to the x over y times y prime is equal to 2y squared minus 3y squared y prime. I think it's so much easier to solve for y prime when all of the parentheses are gone. Now we're going to put the y prime terms together. I'll move that one from the right to the left and take the non-y prime term over to the other side. So I'm going to add this to the other side, and I'm going to subtract this from the other side. So I'm going to have a 3y squared y prime minus xe to the x over y, y prime is equal to 2y squared minus this y times e to the x over y. And we get the y prime terms together so that we can factor out the y prime. I'm going to do that with my erasing and moving the y prime out front. I'm going to take this y prime out of both slots. Put it right here. So in the next step, we'll be done by dividing both sides by what's in the brackets there. So our final derivative looks like 2y squared minus y e to the x over y, all divided by 3y squared minus x e to the x over y. Okay?
I don't think I can show you how to see, but I don't know what I did. So now that makes sense now.
What else? You got one?
Number 6.
Can you tell me what it says?
4 plus 3x equals sine times xy squared.
It's like that. Okay. All right, so over here, all we get is the derivative is 3. Here we have to use the chain rule. We take the derivative of the sine and get a cosine of that same angle. But when it comes time to take the derivative of the angle, you've got to use the product rule. So I got to make some more room over here. So the derivative on the left-hand side gives me 3. And the derivative of the sine gives me a cosine. So we're going to have cosine of the xy squared. And now right in here, we're going to do the product rule. First times the derivative of the second will be x times. Well, what is the derivative of the second term? 2y y prime. Then the other way, so I have plus y squared times the derivative of the first. That's just a 1, so I won't even write it. Okay, so there's a couple ways that we can get rid of the parentheses. We can multiply that out, or we can divide by this. Does it matter to you? Then let's divide by the cosine. So we'll have 3 divided by the cosine of xy squared. And now I don't need the brackets around there. Let's put this in alphabetical order as 2xy y prime. Oops. Yep, I moved that over by dividing. And so I have 2xy y prime plus y squared. That y squared term there on the end doesn't have a y prime, so I'm going to subtract it. So I have 3 over the cosine of xy squared minus y squared is equal to the 2xy y prime. And so one more step, right? We're going to divide all that by the 2xy. So I'm going to pull up my handy dandy eraser and do it just in one line. Okay. What else you got?
Number 17. It's y equals parentheses 7 plus 8x close parentheses all raised to 5 over x.
Okay, so there's the function of x on top, the function of x on the bottom. Right? So that's what we did at the beginning. We're going to pull that power down by taking the log of both sides. So over here I have the natural log of y. Here I have the natural log of 7 plus 8x raised to the 5 over x. So in the next step, I put that down. And then you have your choice. You can make that one big fraction and take the derivative now using the quotient rule, or leave it as it is and take the derivative using the product rule. You have a preference?
I did the product rule, so I can.
So let's
see
do
what
the
I did.
product rule. Think of this as x to the -1. And on the left-hand side, we get 1 over y times y prime. And now I'm going to do the product rule. So it's the first times the derivative of the second. The second thing is a logarithm. So it's 1 over u times the u prime. So I went ahead and put the 8 on top. Now the other way. Copy down the logarithm. And I take the derivative of 5x to the -1 and get minus 5x to the -2. Yes? Okay. And then the last step is to multiply by y. So we're going to put all that in brackets and put that in front of it. I can go ahead and multiply the 5 with the 8. 5 times 8 is 40. Oops, let me put the y in front. Let me put the 7 plus 8x to the 5 over x. Now we put the 5 times 8 is 40. X, 7 plus 8x. Let's put this as a minus 5 here. Times the natural log of 7 plus 8x. All of that over x squared. I kind of simplified as I did it. Can't see a thing out of that one, so let me put the. I'm just gonna apologize for the state of the. Another thing I can do about it. Bummer. Bummer.
Let me try to put that again because I have all that right. I just didn't go to that very last simplified. So
Okay. You guys are gonna be expert typers by the end of the semester. Oh, we gotta enter all this math.
Sometimes it's just a matter of keeping track of parentheses.
That's true. So I try to write it with the less amount of parentheses. That's why I'm putting the 5 at the 8 and stuff like that.
this is thing usually it's not you know highlights it mine's like not doing that. It's just saying like one is incorrect. Maybe it'll work.
What else we got?
I was definitely
9. Okay,
7x minus 5y squared
equals 1. We find the second derivative on this one?
yes.
Okay, so I want y double prime. Okay, so call for me the first derivative. Tell me how you take the derivative of each term.
7 plus 10y equals.
One more. Then why what?
Oh, y
There you go.
equals
Okay, so now we're going to solve for y prime. Y prime is 7 divided by 10y. Yes,
times y, or is
the y is down here underneath the 7. Right, I subtracted from 7, -7. Subtracted 7 divided by 10y. And to make the second derivative easier, I might even write that as -7 over 10 times y to the -1. And then I don't have to do the quotient rule. I'll just do the power rule. So here comes our second derivative right under the squiggly line. On the left-hand side, we get y double prime. On the right-hand side, that's a constant, so I leave it there. When I bring the power down, that's going to make that a positive 7 over 10. Then I get y to the -2 times y prime. I'm going to put the y to the -2 down here next to the 10 as a y squared. And then where the y prime is, I'm going to put -7 over 10y in. So that's my y prime. I get y double prime is 7 over 10, this y squared here with a positive power. And now my y prime term comes out in -7 over 10 times y goes in. So to make it easier to type, we can multiply straight across and get that y double prime is -49 over 100 y to the third power.
why did we go from, why did it become positive 7 over 10?
I'm taking the derivative here, so I bring the power down here,
Oh, right.
right? Negative times a negative gives me positive, y to the -2. Okay.
Well, you can look at my 17 and see.
Okay. You don't like it?
Well, usually it does. It's good, actually. Yes, yes. My
Okay.
secretary likes
All right.
and just for some tests like that.
Okay.
And then the next is just. It tells me this.
What is the, oh, because you got to finish the other two problems.
Okay, let me
You
check.
got to finish
But
the other two
usually, it
problems.
usually doesn't do that.
Sometimes it does. Okay, let's see. What else?
Number 10, the again, y equals arc sine, and then 2x plus 1.
We're supposed to find the derivative. So we're using our new derivative rules for our 3 inverse trig functions. Let me remind you what they are. The derivative with respect to x of the arc sine of u looks like 1 over the square root of 1 minus u squared times u prime. The derivative of the arc cosine just has a -1 in the numerator. The derivative with respect to x of the arc tangent of u doesn't have a square root sign. It's got 1 plus u squared times u prime. And the derivative of the arc cotangent is the same, but with a -1 on top. And then the derivative with respect to x of the arc secant of u has a square root sign, but also has a u out front and a u squared minus 1 times u prime. And you'll often see the u out front in absolute value bars. So we're going to use that top rule where our u is 2x plus 1. So we're going to have 1 over the square root of 1 minus the 2x plus 1 all squared. And then up here we take the derivative of the 2x plus 1. Let's see if I can fit it in here. Y prime is equal to 1 over the square root of 1 minus my u, 2x plus 1 squared. And then the derivative inside just gives me 2. So you put that 2 on top and write that as 2 over the square root of 1 minus the quantity 2x plus 1 all squared.
This is a girlish problem too.
You're still on that one?
Yes, I just.
Because you had to put numbers in and write the equation on a tangent line or something stupid like that?
Started trying to like talking with these.
Can't let you forget how to write the equation on a tangent line. So keep reminding you.
I don't know.
Got it? You still working on whiteboard? Anybody?
Okay, I have one more.
All righty, I got room.
Okay. Y equals the arc secant of 7 to the x power. Like just 7 is just x power. Yes.
Okay. So let's see if you remember, we derived the rule to take the derivative with respect to x of a number to a power. And it behaves a lot like taking the derivative of e to the x. You get itself back times the derivative of the exponent, but then you get one more term. You take that, you multiply it by the natural log of the base. So mimic what you do for e to the x. Itself back, derivative of the power times the natural log of the base. So we'll need that when we go inside to take the derivative of 7 raised to the x power. So first we're going to use the arc secant rule, where our u term is 7 to the x. So I'm going to put a 7 to the x out front of the radical sign, a 7 to the x, and then square it. And then I'm going to use this rule for the u prime. And I'm not going to need the absolute value bars because 7 to the x is always positive. That's my u. So y prime is 1 over u times the square root of u squared minus 1 times u prime. I didn't leave enough room, so I'm going to just say I'm going to take the derivative of that in the next line. Okay, so well, let's move this over. Do you remember that when you raise a power to a power, you multiply exponents? So let's write this as 7 to the 2x inside here. And I'm going to put the u prime term here. So that's copy it down the way you see it, take the derivative of the power, and then take the natural log of the base. So here's as I see it. The derivative of the power is just 1, and then we get the natural log of the base. And now this is all multiplied. So if you want, you can cancel the 7 to the x. So that y prime is just going to be the natural log of 7 over the square root of 7 to the 2x minus 1. I'm glad you asked that one. Got us to review our a to the u power. So if the base is just a constant, you can use that logarithmic differentiation, or you can memorize the little formula here.
I'm sorry, I'm gonna go through that. So A is, in this equation, A
A
is
is 7.
7.
We have
Okay.
7 to the x.
Okay, so we just take arc secant as we would take the derivative like we learned yesterday,
Right?
times,
And now here's our new derivative rule. Derivative of 7 to x itself. The derivative of the exponent was just 1, and then the natural log of the base.
Okay.
Let me
So
let you try a
this-
new one.
this is our first rule.
That's the outside rule.
That's the, is it chain?
Yeah, we're
Chain
doing
rule?
chain rule.
And then that is
The derivative
inside the
inside.
chain.
That's right.
Okay.
That's right.
Yeah, I know that's.
All right, here, try this one. Take the derivative of f of x equals 10 to the 7x plus 2 power. Derivative of 10 raised to the 7x plus 2 power. So copy down the problem. Tell yourself the derivative rule out loud. Itself, derivative of the power, natural log of the base. Got it? The derivative is itself times the derivative of the power times the natural log of the base. Self times the derivative of the power times the natural log of the base. So I didn't tell you this the other day, but we also have a rule to take the derivative of other logarithms, but that's simply the change of base formula. If you want to take the derivative of something that's a logarithm that's not a natural logarithm, suppose you have a logarithm base 4 of x, and you wanted to take the derivative of that. The change of base formula says that that's equal to the natural log of x divided by the natural log of 4. It says if you're sliding a natural log across the top and the denominator is the natural log of the bottom. Now that's a constant. And so to take the derivative of this, I pull the constant out and take the derivative of the natural log of x. And so take the derivative of that. The derivative with respect to x of the log base 4 of x is done by taking the derivative with respect to x of the natural log of x over the natural log of 4. Since this is a constant, I pull it out. And now I multiply by the derivative of the natural log of x, which is just 1 over x. So if you can remember this change of base formula, which again, I said looks like you're sliding a natural log across the top divided by the natural log of the bottom, then you can take the derivative of any other logarithms. I don't know if I put any of these on your web work, but let's try one right now. Let's find y prime if y is equal to a logarithm base 3 of the cosine of x. First, write that in terms of a natural logarithm, and then take the derivative using the way we take the derivative of a natural logarithm. Here's what the change of base formula looks like. This is still y. I would have the natural log of the cosine of x divided by the natural log of 3. You're going to pull out the 1 over the natural log of 3 and take the derivative of the natural log of cosine of x. That's the 1 over u prime rule. So here's where we take the derivative. So let's label it y prime. We're pulling out 1 over the natural log of 3. In here, I take the derivative of the numerator. 1 over u times u prime. Derivative cosine is a minus sign. So in the parentheses, you have minus sign over cosine. You can replace that with a trig function. What's sine over cosine? So that's a negative tangent. And then the natural log of 3 on the bottom.
Why wouldn't we, like, why wouldn't that just be 0?
Which one?
1 over the natural log of 3.
I'm not taking the derivative of it. I'm factoring out. I'm using the constant times a function rule. Just like if I were to take the derivative of 5x squared, I can hold 5 out, get the derivative of x squared to be 2x, then put the 5 back in and get 10x.
So if we did this as like the quotient rule, like if we did, will we get the same thing?
Sure, you'll just, when it comes time to take the derivative of this, you'll get a 0.
Okay, and
Right, you'll have the bottom times the derivative of the top minus the top times 0 over the bottom squared. And when you do the bottom squared and cancel one of them, you come right back to that. Well, I feel like I cheated you. You did nothing new today. I guess we start related rates on Monday.
that felt like a lot of new.
A lot of new to you. Okay, well, you're welcome to go. I'm not going to go home between my classes. I'll stick around if you guys want to do homework and ask more questions. We got 2 windy days in a row. I'm not going to fight that wind again.